This is example 3 on page 25. So show that cos 5 theta equals 16 cos to the power of 5 theta minus 20 cos cubed theta plus 5 cos theta. Now, we're just going to do that first, okay? So to be able to do that, we need to use, we need to expand cos theta plus I sine theta to the power of 5, and we also need to use de Moivre's theorem. So that is equal to, actually I'll do it down here, cos to the power of 5 theta plus 5 cos to the power of 4 theta times I sine theta plus, now just looking at Pascal's triangle, we can just start from the row 1, 3, 3, 1, then we've got 1, 4, 6, 4, 1, and then we've got 1, 5, 10, 10, 5, 1. So we're going to be working on this line here of Pascal's triangle. Remember, we've got 1, 2, 1 above it. And 1 above that. So we've got cos to the power of 5 theta plus 5 times cos to the power of 4 theta I sine theta plus 10 cos cubed theta I squared sine squared theta plus 10 cos squared theta I cubed sine cubed theta plus 5 cos theta I to the power of 4 sine to the power of 4 theta plus I to the power of 5 sine to the power of 5 theta. Now let's just simplify that, and let's put, we can put real bits together and imaginary parts together as well. So cos to the power of 5 theta. I'm going to do this one next because it's real. So I squared is -1, so we would have minus 10 cos cubed theta sine squared theta. So we've done that. We've done this. This is also real. Now I squared is -1, so I to the power of 4 is I squared squared, which is -1 squared, which is +1. So here we've got plus 5 cos theta sine to the power of 4 theta. They're our real parts. Plus, let's look at our imaginary parts. We've got 5 cos to the power of 4 theta sine theta. I'll just put the I on the end. That's imaginary. This is also imaginary. So we know that I squared is -1. So I cubed will be I squared times I, which is -I. So we've got minus 10 cos squared theta sine cubed theta I. And this last one here, I to the power of 5 is I to the power of 4 times I, which is just I, because it's 1 times I. So we've got plus sine to the power of 5 theta I. So we've got our real parts on that first line and our imaginary parts here on the second line of this expansion. Now, by de Moivre's theorem, we also know that cos theta plus I sine theta to the power of 5 is equal to cos of 5 theta plus I sine 5 theta. So that's what we know. Okay, so therefore equating these two equations, equating real parts in the two above equations, we have that cos of 5 theta is equal to cos to the power of 5 theta minus 10 cos cubed theta sine squared theta plus 5 cos theta sine to the power of 4 theta. Now, we're trying to show that cos to the power of 5 theta equals 16 cos to the power of 5 theta minus 20 cos cubed theta plus 5 cos theta. So we need to substitute for the sine squared theta and sine to the power of 4 theta. So cos to the power of 5 theta minus 10 cos cubed theta times 1 minus cos squared theta plus 5 cos theta times 1 minus cos squared theta squared, because this is sine to the power of 4 theta is sine squared theta squared, which is cos to the power of 5 theta minus 10, expanding now, cos cubed theta plus 10 cos to the power of 5 theta, expanding this, plus 5 cos theta, minus 5, oh sorry, I need to expand that first, be plus 5 cos theta times the expansion of this, plus 5 cos theta, now we need to expand this perfect square, 1 minus 2 cos squared theta plus cos to the power of 4 theta, which is just expanding again. Actually, we've got some like terms here, so cos to the power of 5 theta plus 10 cos to the power of 5 theta is 11 cos to the power of 5 theta, minus, then we've got minus 10 cos cubed theta, now expanding, plus 5 cos theta, minus 10 cos cubed theta, plus 5 cos to the power of 5 theta, which is, I'm collecting like terms, 16 cos to the power of 5 theta, minus 20 cos cubed theta, plus 5 cos theta. The question, it says solve the equation 16x to the power of 5 minus 20x cubed plus 5x. There's actually a mistake there. It should be plus 5x minus 1 equals 0. Okay, so it was just missing that. And deduce the exact values of cos 2 pi over 5 and cos 4 pi over 5. We have to solve this equation now. If we just rearrange, 16x to the power of 5 minus 20x cubed plus 5x equals 1. And then we also have our result from part 1. And so comparing that with what we had done earlier. So comparing that with, remember that we've got cos 5 theta from the previous page equals 16 cos to the power of 5 theta minus 20 cos cubed theta plus 5 cos theta. So if we let x equal cos theta and cos to the power of cos of 5 theta equal to 1, we will get, so as I was saying, if we let x equal cos theta and cos to the power of 5 theta equal 1, these two equations basically are essentially the same. So what we're going to do is solve this. So let's just take 16. Actually, no, we'll start with cos of 5 theta equals 1. So just starting with that, cos of 5 theta equals 1. So using general solution for cos, we have that 5 theta, just looking at your cos curve. We know that the cos of 0 is 1, so 5 theta equals 0 plus 2k pi, which means that theta equals 2k pi over 5, where k is equal to 0, plus or minus 1, plus or minus 2, and so on. So therefore theta, now we do need 5 solutions here. So theta, if we let k equals 0, we've got theta is 0, which we know because cos of 0 is 1. If k is positive 1, we've got 2 pi on 5. If k is negative 1, we've got negative 2 pi on 5. When k is 2, we've got 4 pi on 5. And when k is negative 2, we have that theta is negative 4 pi on 5. So remember, we're solving for x. So in other words, x is cos of 0, cos of 2 pi on 5, cos of negative 2 pi on 5, cos of 4 pi on 5, and cos of negative 4 pi on 5. But now if I put where these are, if I've got cos of 2 pi on 5, that would be there. If I've got cos of negative 2 pi on 5, that would be here. Cos of 4 pi on 5 would be this angle all the way around there. And cos of negative 4 pi on 5 would be this here. Now, we know that, but since cos of theta equals, or cos of negative theta, I can write it either way, but because we know that the cos of negative theta equals cos of theta, Okay, so the cos of negative 2 pi and 5, remember we've got all stations to central, so the cos of negative 2 pi and 5 equals the cos of 2 pi and 5. We also know that cos in quadrants 2 and 3 is negative as well. So the cos of 4 pi and 5 is negative cos pi and 5, and the cos of negative 4 pi and 5 is also negative cos of pi on 5. So we know that cos of negative theta equals cos theta, so therefore x equals cos theta cos of 2 pi on 5, and that occurs twice, and cos of 4 pi on 5, and that also occurs twice. And so therefore the roots of 16x to the power of 5 minus 20x cubed plus 5x plus 1, plus 5x minus 1 equals 0 are what we just wrote above. Are x equals cos 0 cos of 2 pi on 5 twice, and cos of 4 pi on 5 also twice. So they're the 5 roots. Sorry, just moving this out of the way. So let's look at product of roots. So product of roots is cos of 0 times cos of 2 pi on 5 twice, so it's cos squared 2 pi on 5 times cos squared 4 pi on 5, and that equals e on a, which is negative 1 over 16, looking back at, or here's our equation here. A, it's negative f on a, because we've got a is 16, b is 0, c is negative 20, d is 0, e is 5, and f is negative 1. So it's negative f on a, which is negative 1 over 16, which is 1 over 16. Now we know that the cos of 0 is 1, so therefore we know that cos squared 2 pi and 5 times cos squared 4 pi and 5 is 1 on 16, or I can write the cos of 2 pi and 5 times cos of 4 pi and 5 all squared is 1 on 16. So therefore, square rooting, taking the square root of both sides, we've got that cos 2 pi and 5 times cos of 4 pi and 5 is equal to plus or minus a quarter. Now, we know that cos of 2 pi and 5 is quadrant 1. Cos of 2 pi and 5 is positive. And we know that cos of 4 pi and 5 is quadrant 2, which is negative. So therefore cos of 2 pi and 5 times the cos of 4 pi and 5 will equal negative a quarter. Now let's look at the sum of roots one at a time. That's equal to cos 0 plus cos of 2 pi on 5, or two of those, 2 cos 2 pi on 5, plus 2 cos 4 pi on 5. That equals negative b on a. Now b is 0, so it's 0. Now we know that cos of 0 is 1. So therefore, we've got 1 plus 2 cos of 2 pi on 5 plus cos of 4 pi on 5. That equals 0. So therefore, cos of 2 pi on 5 plus the cos of 4 pi on 5 equals negative a half. We can form a quadratic equation with these two equations here, equations 1 and 2. So we can form a quadratic equation because we've got the sum of two roots and the product of two roots. So remembering using, if ax squared plus bx plus c is 0, then dividing through by a, x squared plus b on ax plus c on a equals 0. And remember that this is negative b on a, sum of roots, so it'll be x squared. So this will be x squared minus negative b on ax plus c on a equals 0. So we've got x squared minus negative b on a is negative a half. X plus c on a is our product of roots, which is minus a quarter, equals 0. Multiplying through by 4, we've got 4x squared plus 2x minus 1 equals 0. And solving this, so this is the equation or quadratic equation with roots cos of 2 pi on 5 and cos of 4 pi on 5. So solving this quadratic equation, we've got x equals negative 2 plus or minus the square root of 4 minus 4 times 4 times negative 1 over 2 times 4. So x equals negative 2 plus or minus the square root of 4 plus, I think it's square root of 4 plus 16, which is square root of 20, over 8. So it's negative 2 plus or minus 2 root 5 over 8, which is dividing through by 2, negative 1 plus or minus root 5 on 4. So therefore, since the cos of 2 pi on 5 is positive, we know that cos of 2 pi on 5 will equal negative 1 plus root 5 on 4. And also, since the cos of 4 pi on 5 is negative, we know that cos of 4 pi on 5 will equal negative 1 minus root 5 over 4. Of 32x to the power of 5 minus 40x cubed plus 10x minus 1 equals 0, and deduce these two statements. Okay, now we know that from earlier parts that cos of 5 theta equals 16 cos to the power of 5 theta minus 20 cos cubed theta plus 5 cos theta. So this is from our earlier part, so from earlier. So if we multiply through by 2, obviously, so we've got that 2 cos to the cos 5 theta equals 32 cos to the power of 5 theta minus 40 cos cubed theta plus 10 cos theta. So if we let, so trying to solve this equation, so if we let 2 cos 5 theta equal 1 and x equal cos theta, let's first solve cos of 5 theta, therefore equals a half, so therefore 5 theta, cos of 60, which is pi on 3, equals a half, so 5 theta equals pi on 3 plus or minus 2k pi, or 2k pi, sorry, plus or minus, it's 2k pi plus or minus pi on 3. So therefore theta equals 2k pi on 5 plus or minus pi on 15. So theta is, so this is where k equals 0 plus or minus 1 plus or minus 2 and so on. So when k is 0, we've got plus or minus pi on 15. When k is 1, we have 2 pi on 5. Actually, I'm just going to write that with the common denominator first before I go any further. So this will be 6k pi plus or minus pi all over 15. So when k is 0, we have plus or minus pi on 15. When k is 1, we have 6 pi plus pi, that's 7 pi on 15. And when k is a negative 1, we've got negative 6. Actually, we'll just do the k is 1 first rather than the negative 1. So when k is 1, we've got 6 pi plus pi on 15, which is 7 pi on 15, or 6 pi minus pi on 15, which is 5 pi on 15. And when k is 2, we have 12 pi plus pi, that's 13 pi on 15, and we have 12 pi minus pi, that's 11 pi on 15. And if we look at what we're trying to prove, what we might do is just keep going with plus 3 because we're trying to get 19 pi. So when k is 3, we've got 18 pi plus pi, that's 19 pi on 15. And when k is 3, we've got 18 pi minus pi, which is 17 pi on 15. So we won't need to do the negatives because they're just going to double up with the positive ones because the reason we won't do the negatives because we know that cos theta equals cos of negative theta. Okay, so therefore our solutions, remember, are x equals cos theta, which will be cos of pi on 15. Now we don't include cos of negative pi on 15. I'll just put that down here, that the cos of pi on 15 equals the cos of negative pi on 15, so we don't need to include both those. We've got the cos of 7 pi on 15, the cos, this will be cos of pi on 3, the cos of 13 pi on 15. So let's just have a look where these all are. The cos of pi on 3 will be about there. Cos of pi on 15, cos of pi on 15, cos of 7 pi on 15, cos of pi on 3 is here. Then we've got cos of 13 pi on 15 will be about there. Now cos of 11 pi on 15. So we've got cos of 11 pi on 15. Then cos of 19 pi on 15. Actually, I can put this cos of negative pi on 15 there, and we'll just show on the next line how those two are the same. So cos of 19 pi on 15 and cos of 17 pi on 15. But however, there are only 5 roots. And we notice, so I'm going to put the 17 pi on 15 there. However, but the cos of pi on 15, so I'm going to put negative pi on 15 there. So, but the cos of pi on 15 equals cos of negative pi on 15. So I don't need to count that one. And I know that the cos, so if we look at and see what we need, we don't want 11 pi on 15 or 17 pi on 15. So we know that the cos of 11 pi on 15, so that's the same as cos of 19 pi on 15, because they're both equal to negative cos of 4 pi on 15. So I don't need to repeat that root of cos of 11 pi on 15. And we know that the cos of 13 pi, actually, no, we want to have that one. We know that the cos of 17 pi on 15 equals the cos of 13 pi on 15, which equals negative cos of 2 pi on 15. So therefore, the 5 roots that we want are x equals cos pi on 15, cos of 7 pi on 15, cos of 13 pi on 15, cos of 19 pi on 15, and I also forgot the cos of pi on 3, that one there. Okay, so we're not going to use 17 pi on 15, that's a double up, and the cos of 11 pi on 15 is also a double up. Reason we've chosen those is that when they look at sum of roots up here, They don't use 11 pi and 15 and 17 pi and 15. So, therefore, the sum of roots equals cos of pi on 15 plus cos of 7 pi on 15 plus cos of 13 pi on 15 plus cos of 19 pi on 15 plus cos of pi on 3. Now that equals negative b on a, which equals, looking at our equation, b is 0, so it's 0. So therefore cos of pi on 15 plus cos of 7 pi on 15 plus cos of 13 pi on 15 plus cos of 19 pi on 15 equals negative cos of pi on 3, and we know that the cos of pi on 3 is negative a half. Sorry, it's negative of cos pi on 3, which is negative a half. And looking at the product of roots, which is for part 2, product of roots is cos pi on 15 times cos of 7 pi on 15 times the cos of 13 pi on 15 times the cos of 19 pi on 15 times the cos of pi on 3. Now product of roots, because it's a power of 5, it equals negative f on a, which equals negative 1 over 32. So therefore the cos of pi on 15 times cos of 7 pi on 15 times the cos of 13 pi on 15 times the cos of 19 pi on 15 equals 1 over 32 divided by the cos of pi on 3, which is 1 over 32 divided by a half, which is 1 over 32 times 2, which is 1 over 16. Okay? And as required.